All right, this is lesson 5.3b. You may or may not recall, but in chapter 5a, the first chapter section we did, we had 5.3a as a lesson, and then we didn't, that was that, and now we're doing 5.3b. The guided notes are using the textbook, and these are the sections from the textbook, but we sometimes break things up, go back and review some things from past sections and things like that, and that's why sometimes the numbers are goofy like that. But it helps us align it with the curriculum so we know really what we're doing in terms of the textbook, which you never see. All right, so 5.3b is about point ratio form. So point ratio form, it is actually up here on the top here. And these things are also on your formula sheet. If you take a look at your formula sheet, on the bottom left of the first page, we have all the exponential properties, which if you recall, we were working on last chapter. But then up here on the top, there's the standard form of an exponential. That's what we've been working on the last couple of days. Then there's this point ratio form, and then there's transform form. Now, point ratio form, we'll get a little more involved with it, but it's like point slope form for a line. It's a way to write an equation of an exponential equation if you know one point and you know the common ratio. So that's kind of what's going on with that. So let's go back here. Here is for the warm-up. There's two questions asking you to, given this scenario, write an equation of an explicit formula. That's like using standard form, y equals ab to the x, okay? That would be when it says write explicit. Point ratio form is also explicit. It's just something where you have an x and a y in it, okay? But we haven't really talked about that yet. And then you can figure out how what the value is after 10 years or 7 years, whatever it asks for. So go ahead and do that. All right, let's take a look at these answers. So if you buy a house of your dreams for $500,000, it appreciates, goes up in value at a rate of 3.6% per year. That's pretty good if your house is appreciating at that rate. Houses do not appreciate the same every year. It depends on the market and what's going on with the economy and everything else. But in any case, B then would be 1 plus R. So 1 plus, and then move that decimal place over 0.03. I'm adding it 1 plus that because it's going up. It's appreciating. You want to multiply by a number larger than 1 if you want the value to go up. An explicit formula goes with the form y equals ab to the x. And so I put the starting value of 500,000 in there. B is 1.036 to the x. And then I can figure out what the value is after 10 years by putting 10 in for x. And I get, after 10 years, my house would be worth $712,143.57. Now, that's not exactly what happens with houses. We've had some housing things. We bought our house in 2005, this house, and we bought it kind of high, and then everything dropped. And so actually our house was worth a lot less than what we bought it for, which would have been really bad, except that everyone else's house dropped too, and we haven't had to move. So it doesn't really matter what your house is worth if you haven't had to move. So it's a storm outside. It may feel like we're doing this at night. That's really scary out there, but it's because of and I put a light on and then it was like weird. The camera was weird. So I just went like that. It looks like I'm in the dark and that's totally fine. Number 2, you buy a car for $25,000. It depreciates. So it's going down in value. Okay. At a rate of 15% every year. So I move the decimal place over to 0.15, and I'm going to subtract this from 1 in order to get B. B equals 0.85. Explicit formula, again, y equals ab to the x, so y equals 25,000 times 0.85 to the x. Put in for the value after 7 years, put a 7 in for x. Your car will be worth $8,014.43 after 7 years. Again, both these problems, I rounded it to the hundredth because it's like money and we round to the cents, right? So a $25,000 car after 7 years is not worth a whole lot. Even if your car is actually worth $8,000 after 7 years, that's probably pretty good. Obviously depends with cars on how many miles are you driving and what condition is it in. Like our Honda Civic, which our kids have had, one of our children in particular, just puts a lot of dents and scratches in the car. Just runs into things, little parking lot issues. That car is not worth as much as it could have been if it didn't have scratches all over it. Oh well. So Example, so now here's point ratio form. So if an exponential equation, or sorry, if an exponential curve passes through the point x1, y1, and the function values have ratio b values of x that differ by 1, the point ratio form is y equals y1 b to the x minus x1. Okay. Oh dear. So these are very easy, these problems here. All you do is plug in the things that it gives you. So in this problem, it says write two different exponential equations for the following in point ratio form. The base is 2. So it's telling us b is 2, and we need that. Y equals, I'm writing this equation, y1 b x minus x1. If you want to memorize an equation, then you should write it down every time you start a problem. All right, I turned the light on now. Maybe that'll help. It looked bad before, weird, but it is kind of stormy out there. All right, so I'm going to now just put this in here, y equals y1. Now, if I use, let's use this point here first. If I use this point, this is x1, this is y1. So 6, and then b, it said was 2. So I usually put it in parentheses just so that it's separated from that 6. And then x minus x1, x that stays there, minus x1, minus a negative 3 would be plus 3, like that. That would be point ratio form. And the other one you could do, if you use this point here, right, then you could do, scroll up, you could probably do that one actually. You know what? You could probably do that one on your own. Use that point and do that one. All right, and hopefully you got, let me erase this up here, y equals 1.5 times 2 to the x plus 5 for that one. Just remember point ratio form, just like point slope form. When we did point slope form back in chapter 3a, I was like, what do you need to write an equation in point slope form? Well, you need the point and you need the slope. Point ratio form, same thing. You need a point, which we were given, and you need the ratio. And the ratio is the common ratio b. Okay, so you can write something in point ratio form if you have a point and the ratio. If you have something in standard form, right, if you want to write it like this, well, then you need the start value. You need the y-intercept. You need to know that a right there is kind of where you're starting from. It's also technically the vertical stretch in that scenario. And so that is something you would need, but we weren't given that. In this problem in our notes, they didn't tell us where we were starting from. It just gave us a point on that exponential curve. So then you can write it in point ratio form. Now this next page is one problem. It's a big, long problem, and it uses so many properties that we've learned about exponential equations. That's kind of cool, but it's a pretty advanced problem. So make sure you are doing what you can here to make sure you can understand this, right? But again, it's kind of using everything, which is exciting. So it says here, Casey hit the bell in the school clock tower. I imagine this is like Harry Potter, there's that clock tower and there's a bell up there that rings every so often. So everything's very dangerous. She's up there, he's up there, hits it, okay. Oh, her. Her pressure reader measured the sound intensity or loudness at 40 pounds per square inch after 4 seconds had elapsed and 4.7 pounds per square inch after 7.2 seconds. She remembers from her science class that sound decays exponentially. So maybe you knew that or didn't know that, but when you strike something, let's just kind of start right here. It's really intense at first, right? And then it kind of, over time, then will kind of decay, right? Decay like that until the sound is nothing. All right. So she's got basically two pieces of information she knows. She knows that, and time is usually, when you do these problems, time is almost always the x value and the y value. In this case is like sound intensity. So at 4 seconds, the sound intensity is 40. And at 7.2 seconds, the sound intensity is 4.7. Pounds per square inch, that's how much pressure like is on her eardrum from that sound. So 40 pounds, if you think if your eardrum was a square inch, which it's not, it's much smaller than a square inch in terms of surface area. But if it was a square inch, it'd be 40 pounds pushing on that square inch. Okay, so any time you think of PSI, same with your tires. If you pump them up to 30 pounds per square inch, that's PSI. And if you, that means for every like square inch of rubber that's inside your tire, that's what it's pushing out. It's pushing for every square inch, 30 pounds of pressure it's pushing on there. Okay. You do that to your eardrums over the years and you go to loud concerts or stuff like that. People who are in the music industry, that often happens. You can put a lot of damage to your ears because of all that pressure that your eardrums have had to kind of deal with. Now, we could just for fun here, say, okay, just plot a couple points just because it kind of helps us. So at 4 seconds, there's 40 pounds of pressure. And then let's say over here at 7.2 seconds, there's 4.7 pounds of pressure, just to kind of, and then, at the starting value, there was like a lot of pressure. It was really loud, okay, at the beginning. We don't know what that is, but we will find out. So now it says here, find an exponential equation that models these data points using point ratio form twice and setting equations equal to each other. So this is something, as we do these problems, you're going to have to practice because it's, like I said, it's kind of several steps. So I'm going to start by, I'm going to do it twice, it said. The first one, I'm going to use this 40. Okay, this is x1, this is y1. And I'm going to put y equals 40. B, I don't know what the common ratio is. I do know this is decay, right? So B should be between 0 and 1 because it's going down. It's decay. And then x minus 4, like that. And then the other one, okay, is I will write the equation out because I'm trying to memorize it. And I know if I keep writing it out, I will become more familiar with this equation. This will be my x1, y1. So y equals 4.7. I don't know what b is. And then x, x minus x1. I will plug in my computer. And this is like a system of equations in a way. I have right now with this orange one and the green one, these two equations, if you look at them, there's basically two equations. They have a y in them. They have an x in them. You know what? I didn't write this one right. Let me just fix this. This should say x1 was 7.2. So these two equations, there's an x in them, there's a b in them, and there's a y in them. Okay, they have those things in common. And what I'm going to do now is set them equal to each other. They're both the same curve. And so for any given x value, they would get the same y value out, right? If we had this is correct, and these 2 points are actually somewhere on this curve, then for a given x value, you would get the same y value. So the y values would be equal at any given x moment. And so I am going to set these two equations equal to each other. I'm going to say, well, if this is the same, these points are on the same curve, then 40b to the x minus 4 must be equal to 4.7b to the x minus 7.2, like that. All right. Now, we did a problem sort of like this in the last section of notes. What we're going to do is get the b things over to one side, and we'll get the constants or the coefficients over to the other. I will get the b values. I think I'm going to move them. Let's move them to the, see what I did here on my notes. I moved them over. I divided by b to the x minus 4. It wouldn't matter. You could go the other way and it would work just fine. Okay, so I'm going to do that. B to the x minus 4s are going to cancel out here. Still have 40. I have 4.7. And then this is b to the, I'm going to subtract the exponents, b to the x minus 7.2 minus, and here's the one trick that often students don't do. You're subtracting this whole thing, x minus 4, okay? So this negative has to be distributed, and this is going to be the same thing as 40 equals 4.7, b x minus 7.2 minus x plus 4. That's going to clean up. I'm just kind of going along here. X minus x, that goes away. Negative 7.2 plus 4 is negative 3.2. And what happens in this problem is kind of interesting, is the x's just dropped out. And that's good because prior to that step, you had two variables, x and b, in your equation, and you just had one equation with two variables. That usually is unsolvable and it's not going to work, but it does work in this case. All right, now I'm going to move along here. I'm going to get my numbers over to one side. So I'm going to divide by 4.7. Okay, now we're going to divide. So 40 divided by 4.7. If I do that on my calculator, 40 divided by 4.7 gives me 8.511. Let's say 8.511. So I'll do it up here. 8.511 equals, and then on this side I just have b to the negative 3.2. Now this is a power function, so to get b, or to solve for b, I'm going to raise both sides, this looks a little messy, to the reciprocal, which is negative 1 over 3.2, or you could say 1 over negative 3.2, it doesn't really matter. B, and this is negative 3.2, raised to the reciprocal. This is how I get rid of that ugly exponent, negative 1 over 3.2. These will, when you multiply a power raised to a power, you're just going to get b. And on this side, if we do in our calculator, that number, right, 8.5, I could use all of those decimals to the, and then we're doing negative 1 divided by 3.2, like that. And I get 0.512. Let's use it to the thousands. The thing about exponential equations with bases is if you cut it off, if I said, for instance, like 0.5, we're going to start getting really different answers as the seconds go on. If one person uses 0.5 and the other person uses 3 significant digits, just because it's exponential, you're multiplying by the number many, many times, if the numbers would kind of have an effect on the accuracy over time. So it's okay in this case, since it's we're trying to accurately predict the sound pressure over time, to use more decimal places here. Okay, so now that was B. That's what we found. That is not finding an exponential equation like it asked for. However, now that we have B, back up here at the beginning, we had this green equation and an orange equation. Either one of these works, okay? So if I want to do the green one, okay, I could do, I could use this equation here, and I could write an equation y equals 40 times 0.512 to the x minus 4, okay? Or I could use this orange one, right? And that one would be, I'll write that down here. I know this is giving us a lot of stuff here. Y equals, this one, it was 4.7 times 0.512 raised to the x minus 7.2. Either of those equations should be the same, okay? They're both written in point ratio form. They are both using points that are on this graph, okay? So now I have an equation, and I could ask you, what was the sound intensity at 2 seconds? What was the sound intensity at 10 seconds? And you'll be able to plug in numbers and calculate that. what this problem says is, what is the sound intensity at 0 seconds? How loud was it at 0 seconds? Now, this is going to be, I'm going to use, it doesn't really matter, but let's use the one with the 40. Y equals 40. Either one of those equations would work. 0.512 to the x minus, and x is 0. 0 minus 4. So if I use that and I put that into my calculator, now 0 minus 4 is negative 4, right? But you could just type it in that way. 40 times 0.512. It seems to be a struggle, you know? To the, and this is going to be, I'll write 0 minus 4 here, but you could also just write negative 4. And you get 582 point, let's say 0.8, okay? So 582.08, all right? Now, that was at time 0. And so the next question says, write an equation in standard form. Well, standard form looks like this. Y equals a b to the x. And you know a now. A is the start value at 0 seconds. How loud is it? So you can write it in standard form pretty easily if you find out at 0 seconds what it was. So y equals 582.08 times 0.512 to the x. So in standard form, we don't have that x minus whatever, x1 thing. It's just raised to the x power. That's a different form of the equation, and it's a little bit neater and nicer. Now, E says type in all three equations, the 2-point ratio ones you have, the green one and the orange one, and the standard form one on Desmos, or your calculator to see if they're all the same. Now, if you do it on your calculator, you're going to have to change your window size so that you can see it. Desmos is a little bit easier to do this. If I do this on Desmos, now here I'm going to start with this first one, and I'm going to see if I can get this, change it to this now. Maybe I can do this. All right, so if I look at this, this is kind of a weird looking curve, right? It goes way, way up. Remember at 0 seconds, it's kind of somewhere around here, right? That's where it crosses, right, on this equation. And all of these, whether I use the point ratio form looking at the left at all the different equations, no matter which equation I use, these are all the same equation. You would see the same curve. If you want to spread this out because it's so large, one thing you can do, we've done this before, if you go to your gear here, let's just change x to like, let's just go from -1 second to like 10 seconds here. And then we can, it'll kind of spread this out so it's a much nicer looking curve, right? So there's a start value. You could kind of scroll along here like, oh, at 4 seconds, I should be at 40. So if I scroll along here, at 4 seconds, right about there, right? It's about 40, right? And then if I went and scrolled at, what was the other one? 7.2 seconds, right? Those are all the points on there, and all these equations are the same, whether you write them in point ratio form or you write them in point slope form, or not point slope form, standard form or point ratio form, they all work. So that's the end of this lesson. That's a big problem. Really do try to do this problem on your homework. And then when we get to the review, doing it, because there's one like this on the test, it's kind of an advanced problem that you should be able to do. If you have questions, please ask.